Hello, Namaskar, good evening. Welcome to yet another Facebook Live session organized by the JEE team here at BYJU'S. Now, you had a few sessions before this. One of the sessions that was dedicated to giving you general insights about the JEE exams, both the advanced and the main exams. And then we thought, why not give you an insight into different subjects by looking at chunks of chapters rather than the entire subject. So we began by giving you a session in chemistry, and then we had a session in physics. And now it's time for mathematics. So this is the first mathematics session that we are giving from here at BYJU'S. So in this session, we've decided to give you calculus. Now some of my audience who are still in 11th standard might be wondering, why have we started mathematics by looking at calculus? Well, it's a very valid question because calculus is not covered, let's say, until the first half of 11th standard is done. But still then I start with calculus. The reason being, calculus is one of the most important sections. Now this is a standard answer which every teacher likes to give. You ask him a convoluted question, he says, this is very important and that's why I'm doing this first. We believe in a different kind of education. We believe in making learning fun, and as long as you don't have clarity on what you're doing, learning can never be fun, isn't it? So I'm going to tell you, why am I beginning with calculus? Yes, indeed, it's important. Not just in mathematics, but in almost everything that you'll be doing in science. Let's take the case of physics. What was the first unit that you covered in physics? Mechanics, right? What was the first thing you learned in mechanics? Newton's laws of motions. And how did they teach Newton's laws of motions to you? Newton's laws of motion was taught to you through differential calculus. They said velocity is ds by dt, rate of change of displacement with respect to time. Now people who don't know calculus might have been wondering, what's going on? That is why it's so important that you start mathematics, especially when you're preparing for an exam such as JEE, by looking at calculus. So now what is actually calculus? Of course, I'm not going to waste the time of this live session by explaining to you what calculus is, but I'm going to still try and motivate you as to why do you need to learn calculus. Now calculus is the study of change. I'm not going to elaborate on this. For a very, very elaborate motivation as to why should calculus be learnt, refer to our videos. Our product gives you some amazing videos, and in the 11th standard videos, especially on the chapter on limits, the teacher there has done an exceptionally good job in introducing calculus in the best possible way. So, as I was saying, calculus deals with change. Now, why is change important? Our life is very dynamic, isn't it? How many of you can sit in the position that you're sitting in for, let's say, more than half an hour? I can't. That's why I'm going to keep this session for a maximum half an hour, because after half an hour, I can't sit in the same place. I have to move around. Even while sitting, how many of you can sit still? I can't. I've been moving my hands. So the world around you is extremely dynamic. So when you're in such a dynamic world, it's very important that you study this change. And calculus does exactly that. I've told you, in the case of physics, change of position gives you displacement. Change of position with respect to time gives you velocity. Change of velocity with respect to time gives you acceleration. All this is covered by calculus. This is the same case with chemistry as well. If you look at how are electrons changing, how are their probability densities changing, what is Heisenberg's principle, all of these somewhere boil down to calculus. So calculus is very important conceptually. But this is a lot of philosophy, right? Who's interested in conceptual clarity now? Because this is the time for examination. I'm here to tell you how's calculus going to help you in your JEE mains and advanced examination. So let's directly jump into the topic that is there in our hand today, which is how relevant is calculus from JEE, both mains and advanced? Again, same answer. Very, very important. And now I'm a budding mathematician. Mathematicians believe in theories and not, mathematicians believe in theorems and not theories. Why? Because theorems have proofs. We need proof. So anything and everything that I say, for example, I just said that this is a very important thing from the exam point of view. So when I say that, I'm going to prove it to you. And how do I prove it to you? I'm going to give you numbers. I'm going to throw in a few numbers here. Let's look at the last 5 years, 2013, 14, 15, 16, and 17. How many questions appeared from calculus? In the mains exam, in 2013, there were 7 questions. 14, 8, 7 and 15, 8 and 16, 7 and 17. Which means more or less 7, 8 questions come from the concepts of calculus in your mains examination. Now how many questions come from mathematics? 30 questions. 7 or 8 out of 30. You do the math. That's almost 25, 30, 35% of your entire mains examination is from calculus. How many chapters are there in calculus? 6. How many chapters are there in mathematics? 42, which means 6 out of 42 chapters give you 7 or 8 out of 30 questions. This should make you understand how important calculus is from the mains point of view. Don't even get me started on advanced, because there was a year, 2014, in fact 2015, where 14 questions appeared from calculus in your advanced examination. 14 out of 40. Now, that's a massive number. 14 out of 40 is oh my god, that's 35% of my entire paper comes from calculus. So 6 chapters out of 42 gives you such a huge boost. If you know the concepts here, I'm telling you, you can score a lot of marks in your examinations. And the questions that come from here are not really difficult. A little bit of practice, a little bit of insight, and you know how to do these problems with real ease. So now let's get down into the chapters. So we have 6 chapters. I've been telling this again and again. The first chapter. Now this is my favorite chapter. Not because it's the most fundamental chapter. Limits, continuity and differentiability. This is the chapter I'm talking about. Now this is, yes indeed, the most fundamental chapter of calculus. But that's not why it's my favorite chapter. You know why it's my favorite chapter? Because examiners cannot ask tough questions from here. But then they have to ask questions from here. So the questions that come from here are really direct questions. So if you know the concepts well, you can score these questions, you can score marks in these questions like this. And you can guess that you have 90 questions, 180 minutes, which means you can give a maximum of 2 minutes per question. Questions that come from limits can be done in less than 30 seconds. Believe me, if you know the concept, you look at a question, you've done enough number of questions of the same kind, 30 seconds, and you have 4 out of all the number of marks that you have to score in 30 seconds. So limits is my favorite chapter. I always tell my students, never ever skip limits, because limits will fetch you 2 questions. Now in the past so many years, 2013 to 17, let's take the same case, every year there were 2 questions from limits. So limits is an amazing chapter, gives you 2 direct questions. 1 minute, you have 8 marks in your kitty in the mains exam, and also in your advanced exam, you have a lot of marks from this chapter. Now in the chapter on limits, we cover a lot of topics. We look at the definition of limits, we look at the existence of limits, and look at a few theorems. Are all these important? Conceptually, yes, very important. But from the exam point of view, not so. The most important topic, evaluating the indeterminate form. Now you know indeterminate form, 0 by 0, infinity by infinity. There are 7 such different indeterminate forms. So evaluating the indeterminate form is the favorite question of every examiner. A question paper setter has to give a question from this. Now evaluating the indeterminate form fetches 2 types of questions. One which appears in the mains, when they'll give you a limit, the limit will be of an indeterminate form, they'll ask you what is the value of this limit. This is what comes in the mains exam. Now advanced exam, a little more convoluted, right? They can't keep it simple, they have to test you. So what they do is they give you a limit and say this limit is equal to this. But there'll be some parameters whose values you have to find out. These are very, very, very frequent questions. Last 5 years, every year there's been one question where you've been asked to find out one or the other parameter in an indeterminate form. Now why do I say indeterminate form is so interesting? Because there is one tool which makes life amazingly easy. Some people call it the L-Hospital's theorem. I call it the L'Hopital's theorem. So I'm going to stick with L'Hopital's theorem. Now with L'Hopital's theorem, an indeterminate form can be solved like this, isn't it? You know how to solve an indeterminate form using L'Hopital's theorem. Differentiate the numerator, differentiate the denominator, evaluate the limit, you get the value. You don't have to solve things like you solve in your board exam, because no one cares about the steps. People don't allow you to use L'Hopital's theorem in the board exam. But in your JEEs, no one is actually interested in looking at how have you solved it. So L'Hopital's theorem is going to be an amazing tool that will help you score a lot of marks. This is from limits. The most important topic, evaluating the indeterminate form. Most important tool, L'Hopital's theorem. The second part of this chapter, continuity and differentiability. Now both these sections combined will give you another 1 or 2 questions. So the chapter from limits will normally fetch you 2 to 4 questions. Limits, continuity and differentiability, I mean. So from continuity and differentiability, what are the kinds of questions that come? Again, the questions that come from here are pretty straightforward questions, normally from the same subtopic, which is finding out whether a function is continuous or differentiable in a given interval. So they'll give you an interval, they'll give you a function, and then ask, is this function continuous here? Is it differentiable here? If it is not, where is it not differentiable? Where is it not continuous? Now solve a lot of problems which are of this genre and then you can solve these problems within no time in the examination. Now there is a very interesting bit of thing that I want to tell you in the chapter on continuity and differentiability. Now this is because advanced paper setters think that students are quite foolish. We're going to give them a very tough looking question, which is, I'm going to give them a greatest integer function or a modulus function. Now as soon as you look at greatest integer function and modulus function in the chapter on calculus, we go all crazy because these functions are scary. They're not differentiable, they're sometimes not continuous. So if they ask you to find out the differentiability criteria of these functions, students get a little worried. And this is what the question paper setters completely make use of. But I'm going to tell you, these are the questions that I love the most. Why? Not because they're difficult. Actually, they're the most easy questions. You know what? You are not supposed to solve these questions analytically. Don't ever solve these questions analytically. You have graphs for your aid. Draw the graph of a modulus function. See where is the slope changing sharp. And at that point, the function is not differentiable. End of the story. You have a greatest integer function. Draw the graph. You get the step graph. You get the step graph. You know it is not continuous at the point where there is a step. So this is how you tackle difficult questions in your JEE exams. You have to think a little hatke and then solve problems not in the traditional way. Analytically, you do it in the board examination. Graphically, that's what we do in calculus. So limits, continuity and differentiability. This chapter will fetch you a lot of marks. Questions are very easy. So never ever leave this chapter. Very important chapter. If you have any questions, you can definitely write to us. We have a lot of people here working on clearing the doubts of students, and we do that on a regular basis. So write to us in case you are stuck with a problem that is awfully difficult. I'm telling you, there are no problems which are awfully difficult from this chapter. So then, moving on. The next two chapters focus on differentiation. Now, differentiation is the easiest bit of calculus. I love differentiation. Way too early. I don't love differentiation. I love differentiation, the concept, but I don't love differentiation when it comes in exams. You might be wondering, what is this guy saying? He says he loves differentiation, but he doesn't like in the examination. You know what? Advanced and mains examinations are time-bound examinations. You have to solve 90 problems in 180 minutes, or let's say 36 problems in the equal amount of time. So it's time-bound. So there are two ways in which your examiners can test you. One is they can test your aptitude, which is by tricking you. Another one is by giving you lengthy problems. Now differentiation is so easy that question paper setters cannot give you a difficult question from here. They cannot twist questions beyond a certain point. So what do they do? They give you really long problems. It's a great thing that in the advanced examination, questions don't come from methods of differentiation. In 2012, there was a question asked. In 2013, there was a question asked. Ever since in the last 3 years, no question has been asked. I'm so happy because these questions which came in 2012 and 13, it required a good 5 minutes to solve a problem. Now come on, you can't ask a student to solve a problem in 5 minutes in the JEE exams. You're eating valuable time from other questions. So differentiation, let's hope, doesn't fetch a lot of questions. But again, in the mains examination, one question normally comes from differentiation. And I don't like these, though they're very easy questions, they're very time-consuming questions. But this doesn't mean the topic of differentiation is not important. It's a very important topic because it's the basic fundamental topic on differentiation. Now we'll be looking at topics such as the chain rule or logarithmic differentiation, parametric differentiation, implicit differentiation. You need to know all these things. These will come into your aid when you do problems from application of differentiation, which is the next chapter. So methods of differentiation, though will not fetch a lot of questions, and if they fetch will be very long questions, is a chapter that you should know very well. I would say that don't attempt to solve a lot of problems from here, but make sure that on a weekly basis, you go through all the differentiation formulae and this gets embedded in your mind. You should know the differentiation formulae and technique almost by heart. I'm not asking you to by heart anything, but do it so many times that you know these things very well. Next, moving on, application of derivatives. Now this is an interesting chapter. Questions do come from here. 2013 advanced had 3 questions. 2014, 15, 16, 2 questions. In 2017, again 3 questions. And in the mains, every year, 1 question. Now there are 5 topics here. Tangents and normals. Interesting topic. Sometimes questions come from here. Rate of change. Now I've told you differentiation starts with rate of change. Even in physics, you have rate of change questions from differentiation. So rate of change is again going to fetch you questions. Then you have a few theorems. Lagrange's mean value theorem, Cauchy's mean value theorem, and Rolle's theorem. Now in the mains examination, students who are aiming to get into NITs and feel that I can't get into an IIT, if they are looking at the mains examination, they need not look at this, because these theorems will never fetch a question in the mains exam. But the advanced exam question paper setters will definitely ask a question from here, because this is where they can trick students. Questions can be quite convoluted. And then comes the topic on approximations. If you were me, I wouldn't study this topic, because I have not seen a question from approximation almost 30 years. I've never seen a question from approximation. And then comes the most important bit, which is monotonicity, dealing with increasing and decreasing functions, and extremum. So from these two sections, the last sections, lots of questions come. Application of derivatives is mainly about extremum and increasing and decreasing function, which is monotonicity. So if you have a good grasp over these two topics, you should be at least able to get 1 out of 2 questions which come from application of derivatives pretty easily. So application of derivatives is the first of the chapters that I've discussed so far, where you will get convoluted questions. Limits, straightforward questions. Differentiation, they cannot ask you difficult questions. But application of derivatives, the questions can be tricky. So you need to practice as many different kinds of problems as possible. You go through the past 20-30 years of paper and you see that there are a wide range of questions that have been asked from application of derivatives. So any number of problems that you practice from here is never going to be enough. So you have to keep on updating your library on the number of kinds of problems that you have from application of derivatives. An interesting chapter, but then a little bit of investment of time is required to score marks from this bit. So this completes limits and differentiation. 3 out of the 6 chapters are done. Okay, now next we'll be moving to integration. But before that, let me take a few questions, right? It's been me talking all the time. I'm not the kind of teacher who likes talking all the time. I want questions from my students. So, Jamin Mystery asks me how to master integrations. Well, I've not yet started integration. I'll give you an answer to this question, Jamin, in about, let's say, 5 minutes time. And Shubham Shah is asking me how to calculate the maximum value of any number. Now, this is not a session where I can tell you how to solve a problem. I mean, I can give it to you, but then it's going to take some time. So maximizing, you cannot maximize any number. You can maximize a function, and in order to do that, you'd use application of derivatives. In order to maximize a function, this is a topic that comes from extremum, or let's say increasing, decreasing function. It's an extremum topic, how to maximize volume, how to minimize area. All these are topics from extremum. So from extremum, we have very interesting questions, and this is, as I've said, a very important concept. Let me take one more question before I move on. So Vinod Tanwar here says that what to do in these days preparing for math, and suggest us a good book for JEE. Now from this question, I feel that he's in his 12th standard, last 6 months before the examination. This is the time you can put in maximum amount of effort. Your portions will be done. You've covered the entire bulk of chapters that you have to cover, and now you have to focus. Calculus, a very, very important concept. At least once a week, make sure that you solve 30 to 50 problems from calculus, because I've told you calculus is going to fetch you a lot of questions. So calculus, a lot of practice is important. Now you might be wondering, why do I have this book here? He asked for a book. This is the book I suggest, which is it is a Tata McGraw-Hill publication 2008 book. It's not the latest edition, but this book is amazingly good. This is the only book that I'm going to suggest. I'm not going to take names of Arihant and Sengage and Dinesh, because all of them have a lot of questions. Almost everyone is similar, but this book by Tata McGraw-Hill is unbelievably good. Questions that are there in this book have been asked again and again in your examination. There's one more thing. There's something called the Shom series, 1100 questions in calculus. Even from this, questions have been directly lifted and asked in the advanced examination. And the most important thing for your exam is go through past papers. See at least 10 years. If you're a good student, 20 years of past papers, and do all those problems. That will help you a great deal. So I'll take the rest of the questions in the end. Now we move on to integration, because one of the questions that came was how to master integration. And that's a very interesting question, a very good question. Do you know why? Because if there's one chunk in your PCM that is most important, that is integration. Because integration is going to fetch you crazy number of questions. I've already told you in the year 2015, the question paper setter went crazy. He asked bloody 8 questions from just one chapter. Definite integrals. 8 questions from one chapter. Now that's insane amount of importance given to one chapter. And that's been the trend. A lot of questions come from definite integrals. But before definite integrals, it's time for introduction to integrals, which is done through the chapter on indefinite integrals. Now the chapter on indefinite integrals will introduce you to a lot of things. I mean, this is a fundamental chapter of integration, so it'll introduce you to the different tricks of integration. Now, the question that was asked to me is how do you master integration? You have to master this chapter to be able to understand and master integration. You have to concentrate a lot on this chapter. This chapter will not fetch you questions. I'm telling you up front, this chapter will not fetch you questions in the advanced examination. In the advanced examination, in the past 5 years, never has a question directly come from indefinite integrals. In the mains, one question is always asked from indefinite integrals. However, this chapter is vital. It's a foundation to understand the next two chapters, definite integrals and differential equations. So, what are the topics that are covered here? They cover a lot of things. They cover topics such as integration by substitution. Now, integration by substitution, most important. I don't think you can solve any problem in JEE or any competitive exam without using integration by substitution. At some point or the other, you will be asked to substitute something by another in order to get to the solution. So integration by substitution is pretty vital. It's the most important thing that you can find in this chapter on integration. Then there are certain techniques such as integration by partial fractions, integration by parts. All these also find regular use. And then there are standard integration substitutions, standard integration formulae. Integration is more complicated than differentiation, so you have to invest a lot of time in this chapter. So indefinite integrals will not fetch you questions, but it's very important that you pay a lot of attention in indefinite integrals, because if you pay a lot of attention to indefinite integrals, definite integrals will become a little more easy. And definite integrals, one hell of an important chapter. I've already told you again and again that this is the single most chapter that gets maximum weightage. A lot of questions that come from definite integrals will test your knowledge on property of definite integrals. There are about 20 properties that this book mentions. In fact, there are more properties, but I would say that the 20 properties that Tata McGraw-Hill says, and all these 20 have been put in our product. If you look at the BYJU'S study material, in our study material, we have formulated these 20 different properties. And these 20 properties are the most important properties that you can find in definite integrals. And to solve problems, you should know these at the tip of your fingers. I mean, you look at a problem, you should know that this is the property that I need to use. Only then can you master integration and solve integration problems which come from definite integrals. The problems in definite integrals normally appear in the advanced examination. In the mains, 3-4 questions sometimes come from definite integrals, but in the advanced, it's always 7 or 8 questions which come from definite integrals. So definite integrals and area under curves. Now this is an application of definite integrals. So whenever you have a definite integral is nothing but area under a curve. Sometimes they are going to ask you very complicated looking functions. Try and plot. Just like I told in limits, try and plot. Once you plot, things become very easy. A lot of complicated looking problems can be done easily by just drawing a graph. So you should know how to draw graphs of functions to do calculus in a very easy and efficient way. So definite integrals, I've already told you, properties of definite integrals, quite an important topic. These properties will be, your knowledge on these properties will be tested again and again in all the different problems. Area under curve, area bound between curves. Again, all these are going to fetch you a lot of questions. So one advice on definite integrals is solve a wide variety of problems and try to solve these problems using different techniques. What I mean by different techniques is approach it using, let's say, one standard thing that the textbook says, and then try to draw it graphically or using another substitution or another property. This way, what happens is you get flexible. You can solve a problem using multiple properties. Some questions you can't do that, but in some questions this is possible. So this way what happens is during your study, you get a better understanding of all the concepts of definite integrals. So definite integrals, single most important chapter from calculus. Questions are not very easy, but with a lot of practice, a lot of variety of problems that you solve, you should be able to handle this pretty easily. And then the last chapter, differential equations. Now differential equations has the term differential in it, but it's an integration based chapter. So you have to first convert something into a differential equation and then solve the equation to get the equation back. So there are two different sections in this chapter. The first one is formation of a differential equation, which is an application of differentiation. You'll be given an equation and from there you have to get the differential equation. This is a differentiation application. And then you have the second part, which is solving differential equations, wherein you are given a differential equation, you have to find the corresponding standard form of that equation. So again, I have always told that differentiation is the easier bit, integration is the difficult bit, and questions will come from the difficult bit. So questions come from the second part, which is solving differential equations. Finding order and degree of a differential equation, forming a differential equation, these are important. but not very from the exam point of view. From the exam point of view, because 2 questions come from differential equation almost always in the advanced exam, and 1 or 2 questions in the main exam. So almost 3 or 4 questions come from this chapter. So you have to focus on questions that are going to give you marks. The sections that are going to give you questions. The sections that give you question are solving differential equation. And in your portion, you are limited to first order differential equations. So first order differential equations, you have 3 standard forms. The first one is variable separable. Variable separable inevitably finds application in every area. So end of the day, even if it's a homogeneous differential equation or a linear differential equation, you'll have to eventually solve it using variable separable. So it's fundamental to know variable separable. Now homogeneous differential equation and linear differential equation will fetch you direct questions in the mains exams, but not so direct questions in the advanced exams. In the advanced exam, they'll give you equations which will not be homogeneous or linear, but then you don't know how to solve anything which is outside this domain. But then there'll be tricks to convert homogeneous and linear differential equations. In fact, convert equations which don't look like these into these forms. So that's a very, very crucial thing. The most frequent questions that come are convert an equation into linear form and then solve it, or convert an equation into a homogeneous form and then solve it. So if you know these things, you should be able to handle differential equations in a very nice way. So let me sum it up. Calculus, a very important section. Why important? Lots and lots and lots of questions come from here. Which is the most important chapter? Limits, very important because direct questions come, very easy questions come. Differentiation, not so important. Application of derivatives, quite important, nice questions come. Indefinite integrals, important from concept point of view. Questions don't come, but it's an important chapter. Definite integral, the most important chapter. Lots of questions come from here. And differential equations will again fetch you questions. So this is calculus. If you study calculus in a very nice way, it is going to help you not only in mathematics, not only in JEE, but in physics, in chemistry, and in the future in your study, in your pursuit of some excellence in the area of science. Science without calculus, well, it's not at all interesting. So if you're doing any branch of science without calculus, I'm not so interested in it. Science needs to have calculus. So now let me take a few more questions before I wrap this session. I see a lot of questions have popped up. So Shravan has asked this question as to how to master differentiation. Now this is in fact it's quite a complementary question of what Jamin asked on how to master integration. So how to master differentiation? Now differentiation has a lot of standard formulae, like what is the differential of sine theta? It's cos theta. How? You have to use the first principles. So in order to do differentiation, I would say go back to differentiability, derive a lot of formulae, and then you don't have to memorize any of the standard formulae, but then you will remember these formulae, in a very nice way because you've proved it yourself. And then you have to have mastery over chain rule. Chain rule is something that people normally forget, and chain rule is very important if you have to master differentiation. And then of course the other techniques. In fact, in anything, if you have to master it, you have to solve as many problems as possible. Practice makes a man perfect. Let's look at the next question. The next question is, okay, this is my 3rd try in JEE, so how can I crack this through math? Asked Sahil. You cannot crack JEE just through math, because if it's the JEE mains, you don't have subject-wise cutoff, but if it's JEE Advanced, you have subject-wise cutoff. But then you can make math your strength. You have to make math your strength. I'm a math teacher. I'm definitely going to tell you that you have to make math your strength. And there are a few sections. I think if you look at the first session of ours, wherein we spoke about generally how to tackle the exams, we said which are the sections that are important. Sections such as binomial theorem, probability, in addition to calculus, will fetch you a lot of marks. And as we go on in this exercise of ours of coming live to you, we'll give you an insight into other chapters as well. But for now, this is a calculus session, and to Sahil I say that solve as many problems from calculus as possible, because you've seen 35% of math is calculus. So yeah, do well in calculus, you can do well in your examination. I have a question coming in from Nandini. I'm studying 11th grade right now, so you might have found this a little over the top. That's okay. How many hours should I study every day to crack JEE main? Will it be possible if I start now, and which books should I refer to? Of course it will be possible. You're still in 11th standard. You have an entire year and a half to crack JEE mains. You have to put in quality number of hours. I mean, some students can put in 8 hours and crack JEE. Some can put in 4 hours and crack JEE. It is up to you. You have to practice a lot of good number of good quality questions, but you should know that what is your capability, and you should try and put in a lot of efforts into understanding the concepts. And that is where our product comes into picture. Our products are giving you videos wherein you can understand the concepts really well. And once you have conceptual clarity, JEE Mains at least is straightforward. You don't have a lot of complicated problems. JEE Mains will look at how much concept clarity you have, straightforward problems. Look at our videos, study our videos. I would say the best material at present. There are a lot of books. There are the Arihants and the Cengages, but BYJU'S product is going to be the best one to understand concepts. And I'm going to take my last question and then I'm going to sign off because it's half an hour and I've told you I can't sit in the same place for more than half an hour. So Vinod asks me how to increase efficiency and speed, how many questions to solve per day. To increase efficiency and speed, only one thing to do. Practice, practice, and practice. You have to see a problem, understand this is how I have to solve it. Never think how to solve it. It should come to your head like this. And that will come only when you have done a lot of practice. So I hope this session was interesting to all of you, and I hope you will do well in calculus. All the best for your preparation. See you soon. Bye-bye.